Hi Precalc, welcome to the Unit 3 Practice Exam B. Let's get straight to it. So the first part of the exam is going to ask you to factor some quadratic expressions, so a little bit of review. So when we factor a quadratic, especially the ones that I'm presenting to you on the exam, all that have just coefficient 1, we start by taking whatever the variable is, creating parentheses and placing it first. And then we start asking ourselves the question, what two numbers multiply, in this case, to 56, but that add to negative 15? So in this case, I know an 8 and a 7, right? 8 times 7 is 56. But when I add 8 and 7, I get positive 15, not negative. So remember to add the extra little negatives, right? If I add the negatives, then that works out for me. So this would be correctly factored as x minus 8, x minus 7. Nothing more than that. Move on to the next one. This one has the variable a. So when I make my parentheses, I place an a as the first term of both of them. Next, I ask myself, what two numbers multiply to make negative 15 but add to positive 2? So I'm going to need a negative number and a positive number to multiply to 15. I would say, what, a 5 and a 3? I'm going to write down both combinations and I'll think through it a little bit. Upon inspection, I'm like, this second one's going to work. A positive 5 and a negative 3. 5 times negative 3 is negative 15, and 5 plus negative 3 is positive 2. Again, there's no right or wrong order in where if you write the negative 7 and then the negative 8, or the plus 5 and then the minus 3. Either is fine, okay? Basically, remember what we're doing is factoring, just like factoring a number, is finding two things that multiply to make the other thing true. Since the order of multiplying doesn't matter, you can write it in any order. Next one, m squared minus 81. So this is the one where I say, take that, rewrite it as m squared plus 0m minus 81. Okay? Throw in that invisible 0. And when we do that, it helps us see that this isn't so bad. What two numbers multiply to give me, in this case, 81, but add up to 0? That means to add up to 0, I need to have a positive version of the number and a negative version of the number. Upon inspection, we realize the answer should be 9 and negative 9 respectively. Okay, so that's how we factor something like m squared minus 81. It's m plus 9, m minus 9. Last but not least, we get y squared plus 22, y plus 121. Again, so to factor, start by writing the variable y and y, because y times y is y squared. What two numbers multiply to 121 but add up to 22? 11 and 11. So we get a repeated number there. Okay, so that would be the first part of your exam, just some basic factoring review. An essential skill if you're going to keep going past pre-calc, and also just math in general, okay? Now, for the actual part of the exam, for our new stuff, we're looking at the equations of rational expressions. We want to find the x-intercepts, the y-intercepts, any vertical asymptotes, and any horizontal asymptotes, and you got to show the work of how you found the horizontal asymptote. Let's get to it. First one, if I have this expression, 3x plus 4 over x minus 2, what's the x-intercept? So for an x-intercept, remember, we're going to set y equal to 0 and solve for x. So what does that mean? It means here, remember f of x, that's basically our y value. Make that 0. So 0 equals 3x plus 4 all over x minus 2. That's where we start. Now, to solve for the x, we got to get rid of the fractions. Those are tricky to work with. So, as I mentioned in class, multiply both sides by the denominator to clear it. So I'm going to multiply both sides by x minus 2. When I do that, the x minus 2 on the bottom cancels with that x minus 2, and some funky stuff happens. On the one hand, this gives me 3x plus 4, but on the other hand, 0 times anything is 0, so I'm going to write another 0 there. Okay? Let me zoom in here for the viewers who don't have such tiny eyeballs, okay? All right, so we have 0 equals 3x plus 4. And at this point, it's pretty easy to solve, right? To get the x by itself, we'll do inverse operations. The opposite of adding 4 is subtracting 4. So we subtract. 0 minus 4 is negative 4. And the opposite of multiplying x by 3 is dividing x by 3. So we'll divide both sides by 3. Therefore, x has to be 4 over 3, negative 1.33. Okay, that's my x-intercept. So, moving on, to get the y-intercept, let's put that in view. Y-intercept. For this one, we set x equal to 0 and we solve for y. So I'm going to write y equals, and then what was my original expression? It was 3x plus 4 all over x minus 2. So what I'm doing in this one is set x equal to 0. Wherever I see x's, I'm going to replace those with zeros, and then I'll use my PEMDAS skills, parentheses, exponents, division, multiplication, addition, and subtraction, to reduce what I see. So 3 times 0 is 0. 0 plus 4 is just 4 on the top. On the bottom, 0 minus 2 is negative 2. So I just get a negative 2 on the bottom. And so after I simplify my work, 4 divided by negative 2 is just negative 2 itself. That's my y-intercept, negative 2. All right, moving on. The next thing we want to show is how do we figure out the vertical asymptotes? Vertical asymptotes happen when we plug in an x value into our formula, or rational function, and we create division by 0. So upon looking at this, all that matters is what happens in the bottom, right? What number, when I plug it in, will create a 0 on the bottom? What minus 2 is 0? Just 2 itself, right? So we'll say x is 2. Justify your answer by writing the work, right? If I take the expression 3x plus 4 over x minus 2, and I plug in 2, on the top, I'm going to get 3 times 2 plus 4. On the bottom, I'm going to get 2 minus 2. So on the bottom, I have 0, right? 2 minus 2 is 0. And on the top, I get, doesn't matter, it's 10 in this case, but at that point, we're like, yep, that's undefined. If I put that into the calculator, 10 divided by 0, I'm going to get undefined. So that would be the work I want you to show for vertical asymptotes. Okay. Last but not least, my work for horizontal asymptotes would look like this. When we think about horizontal asymptotes, that's asking ourselves, where does my expression go when I plug in bigger and bigger numbers? So let me rewrite the expression, 3x plus 4 over x minus 2. And what I'm going to do is I'm going to figure out what happens as the numbers get bigger. So let's do it with the asked questions. We're plugging in 10. We're plugging in 100. And we're plugging in 1,000. Okay. And so what you want to do while you're taking your test is, with the help of a calculator, do a little bit of math to figure out what goes on top, what goes on bottom, and then do a final division to create some numbers here. I know for this part, 10 minus 2, that's just 8. On the top, 3 times 10 is 30. 30 plus 4 is 34. So in a moment, I'm going to figure out how many times does 8 go into 34. For this one, 100 minus 2 is 98. 3 times 100 is 300, and plus 4 is 304. So in a bit, I'm going to figure out what is 304 divided by 98. And last but not least, 1,000 minus 2 is 998. 3 times 1,000 is 3,000, plus 4 is 3,004. Okay? So this is where we'll use a calculator to figure out these numbers, okay? I'm going to use Siri here because I'm teaching this video and I can do it, but you'll use your calculator when you get the chance. What is 34 divided by 8?
34 divided by 8 is 4.25.
Okay, so this is 4.25. Okay. What is 304 divided by 98? And Siri gave it to me silently this time. It's 3.102. Cool. And let's do one more. What is 3,004 divided by 998?
3,004 divided by 998 is approximately 3.01.
Okay, so when we look at the numbers, when we plug in 10, we get 4.25. When we plug in 100, we get 3.10 with some change. When we plug in 1,000, we get 3.01. So at this case, if we wanted to be really paranoid, we would chuck in not 10, not 100, not 1,000, maybe 10,000. And we would maybe see that it's getting even smaller on this end, 3.000 something. So that leads us, hopefully with some confidence, to guess that as x goes to infinity, as we plug in bigger and bigger numbers, on 10, and 100, and 1,000, where does my expression go? Where does the expression 3x plus 4 over x minus 2 go? It slowly takes on the value of just 3. Okay, so that would be the work you'd want to show to get full credit there. Okay. Now, the video is about 9 minutes, so that's taken about 10 minutes, and if we look at the scale of what we've done, we're basically almost done with the test. The last little bit of the test is just doing it again with one more rational expression, and that's it, okay? So totally fair for half an hour. All right, let's get down to the last part here. If we can get this done in, 5 minutes, that'd be awesome. But again, you would have that extra time. Let's go. So for this one, let's start with x-intercepts. To get an x-intercept, we're going to set the y equal to 0, and we're going to solve for x. So our y value is this g formula. Let's say that turns to 0. On the top of the g formula, we have x squared minus 64. On the bottom of the g formula, I have all this stuff. X squared plus 4x minus 32. So our first step, as we did that other time, was to solve for x. Let's get rid of the fraction. Let's multiply both sides by the denominator of x squared plus 4x minus 32. When I do that, that clears the bottom here, clears the bottom there, and what it remains is x squared minus 64, right, on the right-hand side. On this side, again, remember, 0 times anything is 0, so we basically just get rid of the bottom. We just focus on the top. If 0 equals x squared minus 64, if I add 64 to both sides to try to isolate the x, that leads me to 64 equals x squared. So if I really stop and think about this, this is saying some number, and let me zoom in for the people who can't see, right? This is saying some number, when I square it, when I multiply it by itself, I get 64. So if you think that means x has to be 8, you're correct. But remember, there's another answer. X can also be negative 8. Negative 8 times negative 8 is also positive 64. So I get two final answers there, two x-intercepts. There's two places where if I put this onto a graphing calculator and I made a bunch of funky wiggles and lines, it would cross through 8 and negative 8. Okay? All right. So that's the x-intercepts. Let's move on to the y-intercepts. Put that over here. All right. When I'm solving for a y-intercept, the idea is now I'm going to set x equal to 0, and I'm going to solve for y. Let's show that work. Y equals, I think on the top, was it x squared minus 64? And on the bottom, x squared plus 4x minus 32, right? Okay, so what I'm saying here is I'm going to replace all the x's with zeros. So instead of x squared, it's 0 squared minus 64. Instead of x squared, it's 0 squared plus 4 times 0 minus 32. So notice what this does is because we're plugging in a bunch of zeros, it kind of simplifies the work. On the top, we get left with negative 64, and on the bottom, we just have the minus 32. Everything else doesn't contribute anything to the sum. All right, so logistically speaking, right? Negative divided by negative is positive. How many times does 32 go into 64? The answer should be 2, positive 2. That's my y-intercept. Okay, now, vertical asymptotes. Let's get to those. So for my vertical asymptotes, we need to look at the original expression, x squared minus 64 all over x squared plus 4x minus 32. And we ask ourselves, what x values, when I plug them in, will create division by 0? That's kind of hard to see in this form. So let's do a little trick, which is factoring, right? If I factor the top, notice that this is one of those add in the invisible 0 problems. X squared plus 0x minus 64. If I write it this way, that means I'm thinking of what are two numbers that multiply to 64, negative 64, but add up to 0. And with a little bit of thought, you'd think, oh, well, positive 8 and negative 8, Mr. Gamboa? And I would say, yeah, you're right. On the other hand, when I factor the bottom one here, I'd ask myself, what two numbers multiply to make negative 32, but add to positive 4? So let's think. 8 times 4 is 32, right? So probably one of these is an 8 and one of these is a 4. It has to be negative, but I have to end up with a positive answer. So I believe this combination works. 8 times negative 4 is the right combination. Add these together, you get positive 4. Multiply these together, you get minus 32. So the reason I do this Instead of looking at this equation, let's look at the equation this way. It's made up of these two pieces and those two pieces. In this form, it's a lot easier to see what the vertical asymptote should be. What numbers can I not plug in? Because when I do, it would create division by 0. From here you can see that x equals -8 is one of them. Because when I plug in -8s everywhere, I'm going to get -8 plus 0, -8 minus 8, -8 plus 8 on the bottom. That's going to be division by 0. Another number I should not use then, therefore, is +4. Okay. If I plug in 4s everywhere, here in that bottom, 4 minus 4 is going to be 0, and that's going to cause a calculator error. So those are my vertical asymptotes. Okay. Last but not least, we get to the horizontal asymptote part, and this is everybody's favorite part, the Nike math. By Nike math, I mean just do it. Just do it. Okay. So let's start. Horizontal asymptotes. Whoa, this thing got crazy thick. Horizontal asymptote. Okay. So for this one, again, we have what? X squared minus 64 on the top. X squared, what was it? Plus 4x minus 32. So when we plug in tens, right? And actually, what I'm going to do is I'm going to use the factored form here. In factored form, we said that this was a +8 and a -8, right? And in factored form, this was also +8 and a -4. So when I plug in my 10, my 100, my 1,000, I'm going to plug it into this form instead of that form. Since they're equal, it's fine. So let's plug in tens. What is 10 plus 8 times 10 minus 8? All over 10 plus 8 again times 10 minus 4 here. Okay, I'm just replacing all the x's with tens. I'm going to figure out what that is, right? I'm also going to figure out what happens when I plug in 100. So what's 100 plus 8? 100 minus 8. 100 plus 8. And 100 minus 4. What happens when I do that? And last but not least, I'm also going to show, what if I plug in 1,000 plus 8 times 1,000 minus 8 all over 1,000 plus 8 times 1,000 minus 4. So something you might notice is when we're doing this, you might say, hey, I have a 10 plus 8 on the top and a 10 plus 8 on the bottom. I have 1,000 plus 8 on the top, 1,000 plus 8 on the bottom. Won't that cancel out, mister? And you're correct. So what I'm actually going to put into the calculator will be a lot simpler. 10 minus 8 is 2. 10 minus 4 is 6. So I'm going to figure out what is 2 over 6. And I already know what that is, right? That's the same thing as 1/3, right? And that's 0.333, right? So that's what we get when we plug in 10. When we plug in 100, we get what? 92, right? 100 minus 8 is 92. 100 minus 4 is 96. And that's a lot bigger. I don't know what 92 out of 96 is, but that's pretty close to 100%. What is 92 divided by 96?
Okay, I found this on the web.
What is 92 divided by 96? Okay, so Siri told me 92 divided by 96 is 0.95.
92 divided by 96.95.
Oh, no, you're fine. What is 992 divided by 996?
992 divided by 996 is approximately 0.996.
Cool. All right, so let's see if we can discern the pattern. When we plug in 10, we get 0.33. Okay, that's positive. When we plug in 100, we get 0.95. Okay, bigger. When we plug in 1,000, we get 0.996. So if you were paranoid and you wanted to plug in 10,000 on the top and bottom, you could do that. Basically, I think that would be like 10,000 minus 8 is 9,992. And 10,000 minus 4 would be like 9,996. And if I ask you what that is, what is 9,992 divided by 9,996?
9,992 divided by 9,996 is approximately 0.9996.
Whoa, okay. So if we plug in something even bigger than that into like the 10,000s, we keep basically adding more nines. In the long run, if I plug in not 10,000, but 100,000, a million, right? we're going to keep getting more 9s, and at that point, basically, the answer is clear. As x goes to infinity, my original expression, the x squared minus 64 all over x squared plus 4x minus 32, that becomes very, very close to the value of 1, okay? In the long run, that's what we're talking about, horizontal asymptotes, okay? So there you go. That is our pre-calculus practice exam B. If you want to know how to do the extra credit, keep watching this video, else you're all done, basically. Extra credit time. Oy. Okay, what if I get a question like this? Jorge works half as fast as Olivia when it comes to cleaning the living room. When they work together, they can clean the living room in 20 minutes. How fast can Jorge clean the living room just by himself? Okay, so for this kind of problem, I recommend writing it out this way. Jorge cleans the room, aka he does the job, the one job, in I don't know how many minutes, okay? So I'm gonna write it as X minutes. Olivia does one job in how many minutes? Now, I don't know how many minutes either of these people do, but I do know that Jorge works half as fast as Olivia when it comes to doing this stuff, okay? So what I could do is maybe put a 2x like that, and then guess, right? Because Jorge works half as fast as her, does this relationship make sense? Let's pretend x is, let's say the answer was 10 for some reason. Let's say Jorge does the job in 10 minutes. That means Olivia, if x is 10, does it in 2 times 10 or 20 minutes, right? Let's look at the numbers, right? Jorge got the job done in 10 minutes, Olivia got the job done in 20 minutes. Jorge works half as fast as Olivia. He's not as fast as her, he's actually like, whatever Olivia does, he does half as bad a job, right? Like if Olivia gets it done in 30 minutes, that means it takes him an hour, because half as fast means he's twice as slow, right? So from that, we kind of noticed like, no, this isn't the right way to do it. Actually, we should switch these numbers around. We should put 2x for Jorge and x for Olivia. And in that way, that makes more sense. Again, if x is 30 for 30 minutes for Olivia, Jorge takes 2 times 30 or 60 minutes. And now it's, again, that half as fast. The takes twice as long, okay? So this should be our setup. And last but not least, I know Jorge plus Olivia gets the one job done. In this case, that I do have a number, 20 minutes. Okay? So what does this table help me accomplish? It helps me accomplish the following. Jorge gets the one job done in 2x minutes, so that can be represented by this fraction. One job in 2x minutes. If I combine that speed with Olivia's speed, which is one job done in x minutes, combined, that equals the one job done in 20 minutes. So we set it up this way. Okay. Now, to be able to actually solve the question here, let's just try to figure out how to add the two fractions on the left-hand side. Remember, I can only add two fractions if they have the same denominator. So here's my trick. Let's multiply 1x, top and bottom, by 2. I can do that because, remember, multiplying by 2 over 2 in this case, that's secretly multiplying by 1. And when I multiply anything by 1, that is not cheating, that keeps the same value. So what this does is, we turn 1 over x into 2 over 2x, right? Because 1 times 2 is 2, and x times 2 is 2x, okay? Now, I have two fractions with the same denominator. That means I can add them. 1 plus 2 is 3 over 2x equals 1 over 20. And at this step, I would do what was called cross multiplication. Anytime I'm saying two fractions are equal, that is true if and only if 3 times 20 is the same thing as 2x times 1, okay? Multiply these two numbers, multiply those two numbers. 3 times 20 is 60. 2x times 1 stays 2x, because anything times x is the same. And from there, I think you can see the answer. 2 times x is 60. X has to be 30. Okay, so as it turns out, if x is 30, if I go back to the table, that means Olivia gets the job done in 30 minutes. So how fast can Jorge clean the room by himself? 60 minutes. So my actual final answer would be Jorge can clean the room in 60 minutes. Okay? And that would be the answer for that. Okay. With that said, I hope you guys have a wonderful rest of your evening, whenever or wherever you're studying for this exam. Good luck and see you in class. Bye.